So we can measure the clearance of a substance, and we do that using this formula that we looked at. But what good is it to measure the clearance of a substance? What does it tell us? Well, it tells us something about how the kidney is functioning, and I'll give you an example. So let's say you had a substance that you knew was freely filtered, but not reabsorbed or secreted. In that case, what did we say? We said that the clearance of that substance would be equal to GFR. So therefore, by measuring the clearance, you're basically measuring GFR. And GFR is really useful to know because that basically tells you how healthy the kidneys are and how well they're working. So what substance can we do this with? Well, we mentioned creatinine. We said that creatinine is freely filtered, but if you remember, we also said that it was actually slightly secreted. So it's not the perfect thing to do for this, but it's pretty good. The perfect thing to use for this is actually something else, and it's called inulin. But inulin is actually a little more inconvenient than creatinine, and the reason is that creatinine is made from muscles, as you remember, whereas insulin is actually not made in the body, so it actually has to be given as an injection, and that already makes it quite a bit more inconvenient to deal with. But in terms of measuring GFR, the clearance of inulin is better than the clearance of creatinine because inulin is not secreted, whereas creatinine is a little bit secreted. So these are substances that are freely filtered and that pretty much are neither secreted nor reabsorbed. But what about a substance that's totally secreted? Well, what does it even mean to be totally secreted? To answer that question, we need to figure out when something gets secreted into the tubules, where is it really getting secreted from? And the answer is basically that it's getting secreted from the peritubular capillaries. And if you'll remember, those actually come from the efferent arteriole. So the efferent arteriole gives rise to a set of capillaries called the peritubular capillaries. And when something is secreted, for all intents and purposes, it's taken from the peritubular capillaries and put into the tubules. Now you're probably very curious how this actually works, and we'll talk about that in future videos. But for now, what does it mean for something to then be totally secreted? Well, it means that everything that's going through the peritubular capillaries gets put into the tubules, every bit of that substance. So then let me ask you, what would the clearance of such a substance be? So if you remember, our first formula for clearance was that it's equal to the amount excreted divided by the plasma concentration. So for this substance, how much is excreted? Well, the key is to realize that if everything that goes into the efferent arteriole is put into the tubule, then that means that everything that was coming into the afferent arteriole ended up in the tubules. Because either it was filtered, in which case it ended up in the tubules, or it bypassed the glomerulus and then it was secreted into the tubule. So therefore, this amount excreted is equal to the plasma concentration of that substance times what? Times the renal plasma flow, because that's all the plasma volume that's coming in through this afferent arteriole. And then we still have our denominator there, and as you'll see, this term and this term cancel, and so the clearance of this totally secreted substance is equal to the renal plasma flow. And so what's an example of a substance that's totally secreted? Well, that would be PAH, which stands for para amino hyperate. But really, you just need to know it as PAH. So if you can measure the clearance of PAH, you have then measured the renal plasma flow. But like inulin, it's not super convenient because where does PAH come from? Well, it has to be given from outside.